Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I am your teacher, Maryam Rafiqu. We have to discuss today chapter number 17, that is static electricity. And the topics are electric field and hazards of electrostatics. Before getting into the core concepts of this chapter, I would like to share some learning outcomes, like what is electric field, representation of electric field lines, some hazards of electrostatics, for example, electrostatic spark or lightning, and some assignment questions. First, we have to understand that what is electric force. An electric force is exerted between any two charged objects, and the objects with the same charge, both positive and both negative, will repel each other, and objects with opposite charges, one positive and one negative, will attract each other. A region of space in which an electric charge will experience a force is called electric field, and the direction of the field at a point in space is the direction in which a positive test charge would move if placed at that point. Now we can represent the strength and direction of an electric field at a point using electric field lines. Now we have to see some basic conventions when drawing field lines. Number 1, field lines extend out from positive charges. Field lines go into negative charges. All field lines are continuous curves or lines without any break. Field lines never cross each other's path. Field lines in the same direction tend to stay as far apart as possible. Field lines in the opposite direction tend to cancel each other. And when electric field strength E increases, that is, the charge is stronger, the number of field lines increases. Field lines are always perpendicular from its source, and stronger field lines retain their shape better, therefore are less distorted by other charges around. Now students, you have to see that the number of field lines is proportional to the charge. You can see the electric field lines around a positive charge, and you can also observe here the electric field lines around a -2q charge. Here are also some examples of electric field lines. Now we have to discuss some hazards of electrostatics. We have to see that electrostatic spark, the electric charges can accumulate on trucks due to friction between road and tires of truck. Sparks may be produced when discharging happens, and this will cause any flammable materials that the trucks are carrying to catch fire or explode. So we have to connect a metal chain at the rear end of truck to the ground to provide a discharging path for excess charges. And you can see in the picture that the static charges flow to earth, that means they are grounding. The next one is lightning. Thunderclouds are charged with a large amount of negative charges, and the charges arise due to the friction between the water molecules and air molecules as the wind shifts them around. And these highly charged clouds ionize the air around it, which causes the air bodies near the clouds to be slightly conductive. The Earth is at higher potential than the clouds. Hence, the negative charges in the cloud will want to go to the ground. And these negative charges will flow through the ionized air that is conductive to the ground. During this process, students, the air is heated up rapidly, which produces the light that is called lightning and the sound that is called thunder. We also observe during this phenomenon of lightning that the negative charges will typically take the shortest path possible between the thunderclouds and the ground. Hence, it is dangerous to stand under trees, swim in the sea, or play in an open field during thunderstorm. Now, buildings, especially tall ones, are frequently subjected to lightning attacks. And if a building is not suitably protected, its structure would be severely damaged in the process. And the lightning rods are now fitted in top of buildings for protection. When thunderclouds are nearby, positive charges are induced on the lightning conductors. The induced positive charges remove the electrons from the nearby air and ionize the surrounding air. The positively charged air then flow upwards to neutralize the thundercloud. Now this is the time for assignment, students. Here is a worked example I am sharing with you, and please try to solve this. And the question is, a light conducting sphere, positively charged, hangs vertically on an insulating thread. When a metal plate on an insulating stand is brought near, the sphere is immediately deflected as shown in figure below. Now what we have to do, we have to explain that why the sphere moves immediately to the new position. And part B, how does the movement of the ball illustrate the meaning of the term electric field? Thank you so much. Good luck.